Hello there, welcome to the learning of engineering tutorials. In this video lecture, we are trying to find what is the column and what is the struts in the mechanics of solids. As we know, these columns and the struts are going to be handled by the two different departments. The first one is going to be the column. As we know, when a member, you can take it any member, that axis is existed in the vertically and only it is going to be subjected to the compressive loads. Then we can say that is the column, right? So best example is going to be the building pillars are going to be the best example where these pillars are going to be always subjected to the compressive force rather than the tensile forces. So the second one is going to be the strut. In this case, what will happen? That means in the columns is going to be the both ends are going to be fixed. One is in the foundation, one is going to be fixed to the floor. Then the compressive load is coming. But in this case, in the strut members, what will happen? So the both ends are going to be either hinged or the pin. Then the load is going to be acting on that member. In this case, in the strut members, that axis may not be the vertical, that's maybe in the inclined position also existed. Then that is going to be calling the strut. The examples are going to be from the mechanical, it is going to be the connecting rod or the piston rod. We are going to be giving the example for the struts. So what exactly we are going to be learn in this video lecture? There we can see the crippling load that we need to determine. So the crippling load when both ends of the column are hinged. So in this case, what happened? Both ends are going to be hinged over here. So for this one, I have taken one graphical image, the pictorial view. So then already we told the either column or the struts, both are going to be subjected to the compressive loads. One case it's going to be vertical axis, another case it is going to be maybe inclined also it is going to be existed. So then in this case, what will happen? I have taken one circular, the column here. So as we told, there is going to be subjected to only the compressive loads over here, and this side as well as this side is the compressive loads are going to be coming. Then what will happen in this case? Can you imagine here that same in this case? So the member is going to be trying to the member is going to be trying to that's going to be contracting in each other from the both ends. So the same figure I have taken over here, that's it's going to be axis of the member. So there we can see one end is going to be, in this case two ends are hinged, A is hinged and B also hinged position I have taken, and the length of the beam I have taken here is the L. The length of the column is going to be the L I have taken. So then what happened here? We have applied the load, the P on this member. So then what is the position of this one? It means that the member is going to be trying to transmit the load along the axis of the member. That's our imagination. So then what will happen in this case? So then in this case, what will happen? So because compared the length is going to be greater than your diameter, right? The length is going to be more than the diameter, then rather than it is going to be compressed, that means the contracting, it is going to be start to buckling in this way. So there we can see the crippling, the load is going to be acting, which is bending the object. We are going to be calling that is the crippling load. So then the load is going to be acting at the point B. So then this is the dotted line is indicating the initial position of the column, and then what will happen because of this load? So then that's going to be start to the stretching. That means here in this case contraction is going to be taking, then it will start to deflecting in this direction. Right? So in this case, what will happen if it is going to be deflecting in this convex, so in this case, that is going to be concave shape is going to be forming. Then we can say this is going to be the -1. If it is going to be deflecting, if the load is coming and it will start to deflecting in this case, this is going to be the initial position. So then if it is going to be deflecting in this direction, this is the convex shape, so then automatically it is going to be considered as a positive case. So now we can see we need to determine how much amount of the load it can carry. Before it's going to be filled. Can you see y is going to be the deflection of the column, and it is located at a distance of x, because I have taken a point on your column, that's going to be the point C, and A and B are hinged and the P is going to be the load is going to be acting. Then how we are going to be find over here? So we know the y is going to be the deflection. So if I want to find out this one, then I have to take the moments over here. So the moments because of this load as well as the governing equations we are going to be taking, and then we will try to solve that equation. So there we can see because of this load, what is the bending moment? So that's the bending moment the bending moment m is equal to, that's going to be p into, what is the distance it is existed? That is the transverse distance is nothing but your deflection, and it is going to be taking the concave shape, and then it is going to be calling minus. And after that, I am going to be taking the governing equation. What is the governing equation here? That's going to be governing equation m is equal to, that's we derived in the deflection of the beams. So that's going to be ei into d square y by dx square we have taken. So from this one, I am going to be equating these two, equation 1 as well as the equation 2. So that I will try to find out the magnitude of your crippling load. So that is equal to, that is the 1 is equal to suppose if I am going to be taking minus p into y is equal to ei d square y by dx square. So then further simplification of this equation, I am going to be taking this ei and pi, I am going to be taking towards this side. So then final equation d square y by the dx square plus p by ei into the y, that is equal to 0 I have taken. So can you see this equation, this is the second order differential equation we have taken, and then further simplification we are going to be doing here. And I am going to be taking this one, that's going to be the d square y by dx square plus alpha square y is equal to 0. So in this case, alpha square is nothing but, I am going to be introducing one of the constant terminology, that's going to be ei I am going to be taking here. That's going to be alpha square is equal to p by ei I have taken. So then I am going to be solving this equation, that second order. The solution is nothing but, so here the solution I am going to be writing. How we are going to be writing? In this case, we need to find out the deflection. This is going to be the variable. That's y is equal to, so in this case, that's the y is equal to the c1, right, c1 cos alpha comma x, this is the angle, plus c2 sin alpha x I have taken. So in this case, after the integration of this part, and then I am going to be finding the deflection of the system, then c1 and c2 are the constants. So now I want to find out the c1 and c2. If you want to find out the c1 and c2, so then what I want to do, here is the two variables are there, one is the x, second one is the y. So I am going to be taking the two boundary conditions. The first boundary condition, this is going to be the BC, the first boundary condition. So I am going to be considering from the A is going to be the origin. So then in this case, x is equal to 0, which is representing the length of the member, and the deflection at A is equal to 0. Alright. In the second case, what will happen? The x is going to be shifted to a point B. So then second boundary condition, x is equal to L, right? L, then what is the deflection at the point B? That is also going to be 0, because there is a hinged support is there. Due to this reason, at A and the B, the deflection will going to be 0, but whatever the deflection is there, that is existed in the span of the length. So now I am going to be substituting 1 and 2 in this equation. I am going to be trying to find it here. So there we can see first boundary condition, x is equal to 0, y is equal to 0. So x is equal to 0, y is equal to 0. So y is equal to 0 here, and then this is going to be the c1, the cos into alpha 0 suppose. So plus c2 sin alpha 0 we are going to be considering. So in this equation, I am going to be considering here, this is going to be cos 0, this is the sin 0. As we know, sin 0 is equal to 0, cos 0 is equal to 1. So then 0, c1 into 1 and c2 into 0. So this terminology will going to be 0, then finally c1 is equal to 0, we got it. So when I am going to be substituting the first boundary condition, so then what I got it, that the c1 is equal to, so right, that the c1 is equal to, I got it 0. Once I am going to be finding the c1, then I will substitute the second boundary conditions to get the c2 value. So here is the second boundary condition, x is equal to L and y is equal to 0. This is at point B is going to be our second boundary conditions. So now I am going to be substituting y is equal to 0. Then already we know the c1 is equal to 0, 0 into cos alpha L, this is going to be 0, and c2 sin alpha x we are going to be getting. Right? This is going to be your boundary conditions, that means once we apply, and this will going to be over here. So 0 means that finally c2 is equal to sin alpha x is equal to 0 we are getting. So in this case, what will happen? So either C2 are going to be 0 or sin alpha x is going to be 0 we are getting. We know alpha is nothing but from that equation we are going to be writing. So C2 is equal to sin the square root of p by pi e, sorry, that's going to be your IE. So that's going to be, this is going to be your L is equal to 0. This is going to be the L. So right, so from this one I am going to be writing either C2 is equal to 0 or sin square root of p by EI into L equal to 0. So then if C2 is equal to 0 means here what will happen, if C1 is equal to 0 and the C2 is equal to 0, then Y is equal to 0. Are you getting here? So Y is equal to, finally the deflection whatever we have shown, that is not deflected. That means here the column of that member is going to be as it is. So then is it true? Actually that is not the true case, because the system is going to be start to buckling because of this, the crippling load. So then we need to find out this one. It means this is C2 is never equal to 0. Then what happened? I am going to be taking this parameter is going to be equated to 0, then I can find out the crippling load. Now we are taking this parameter, we are equated to 0. So then how could you find out the value of the P? So then in this case, the sin this parameter is equal to 0. When this parameter will going to be 0, then when I am going to be taking the sign conventions, the sin equal to 0, comma, sin pi or 2 pi or 3 pi. Suppose if I am going to be taking the any case of this one, instead of the 0, then pi 0, sin 0 is equal to 0. The sin pi is equal to 0, 2 pi, 3 pi, suppose you are going to be taking. Then finally, this value magnitude is going to be getting the 0. But if I am going to be taking the sin 0, so then the P value also going to be 0. Because we know that the load is coming to the member in the axially in the downward direction. It means that the member is going to be subject to the compressive load. So right, suppose for this one, I am going to be taking the least value of the remaining parameters. Suppose I am not going to be taking the sin 0 here. Because sin angle is going to be 0 means the deflection is going to be 0 we are getting. So that's why I am going to be taking the least value is going to be the pi I am going to be considering. So that is equal to, so P by EI into L is equal to sin pi. So further simplification of this equation we are going to be getting here. So that's going to be P by EI, the square root, L is equal to pi. So now I am going to be simplifying this equation. I am taking the terminologies to the right side as well as the left side so that I can get it that equation. So then if I am going to be do that, P by EI is equal to pi square by L square we are going to be getting. So that means I am going to be taking the terminologies to the right side. So then the P is equal to pi square EI by L square we are getting. So this is going to be the magnitude of the crippling load which is acting on this member. Suppose in this case what will happen, can you see here, this is E is going to be your Young's modulus, I is going to be your moment of inertia, and L square L is going to be your length of the member. So on that basis we are going to be getting the final crippling load of the system. So I hope you are able to understand what is the column and what is the strut. In this column there is a vertical axis. In this strut members, the axis may not be the vertical but not the horizontal condition, it is going to be inclined position. The example for the strut is going to be your connecting rod or piston rod, and here is going to be the columns is best example, the building pillars are going to be the best example. In this case, we derived the crippling load by keeping the both ends are going to be hinged position, alright. So then if the two ends are fixed means we can say that is the column. When the two ends are not fixed and they hinged or pinned, then we can say that is going to be a strut. So this way we are going to be calculating the crippling load. So still if you feel any confusion regarding this mathematical model, so please put in the comment section so that I can reach you out. So thank you.